I can say what we have basically two kinds of change we have to address. One of them is just the simple changes, is that we go from 32-bit to 64-bit to whatever. And the way we've done that is we view our APIs as a contract, and we don't change those, so we change the underlying. The issue there, though, is that there will be other changes that are far beyond that. I mean, the move from systems architecture that we have today into a cloud-based architecture is a massive change, and just keeping the same API won't satisfy you because it won't open up the new features. And so that's actually, it's got to be designed into the software, and we try to design a lot of this in.
When you look at upgrading the systems, you have to, I think one of the important things to think about is that in today's environment, power and automation are becoming more and more integrated. And so you want to see the systems that have the ability to have the span and the reach there. I know in talking to utility executives, one of the questions that I've asked them is, what's keeping you awake at night? And utility executives have the same concern as most of the people in this room. All these legacy systems and these certain things that don't exist anymore, and what happens if there's a failure in the middle of the night. So this is a major issue. It's a major challenge, and I think as we go forward, the suppliers and the customers that work together to come up with these end-to-end and what we call edge-to-edge type solutions that have the portability, as the previous person asked, and have the longevity and the upgradability are going to be key.
Yes. I mean, in the past, the business case for a lot of the IT systems, looking at replacement of the legacy systems, everybody looked at these tremendous investments and said, no, we can't get there. But to the point that Alan made, you know, now the integrity of these systems and the dependence of these systems has become so important. It ties back to the comment I made about risk management. Almost everybody is saying, this isn't just a nice to have now, this is essential, and we have to upgrade. So what you've seen and what my intelligence team at Shell found is a lot of major companies are now increasing the bench strength of the people that are doing the business case development for the replacement of a lot of these systems, sometimes in the office of the CIO, sometimes in the central office of strategy in big companies, to really make that business case and be able to get that investment money for these upgrades.
I have to say that although this has been a driving force or discussed a lot, there are lots of old systems out there, and I don't think we'll see them gone, because by the time they get those old ones out, the new ones going in today will be old. And I'm talking about, I see Mod 3s. We just recently stopped maintaining VMS. We only maintain open VMS. Legion, Northrop, Fisher, Porter, Bailey Network 90. I mean, they're all out there, and they're sitting on these $100, $200 million units, and so people aren't going to change them. So realistically, what you have to do is you just have to clean up your interfacing technology. And seeing Tom Burke in the audience, the OPC has been a marvelous asset to the industry, and it's helped us understand that there needs to be interfaces to these systems.
Yeah, good. That's a strong, very good point.
Risk, you know, risk was mentioned before in the discussion, and quite often the customer is not aware of the risk he is facing.
Yeah.
So, and what he really needs, he needs qualified help by auditing his existing installation and give him advice how step by step he could upgrade in order to meet also his budget requirements, and on the other side, combined with the proper risk assessment for the future.
You know, Dow has started its journey in developing its own process automation systems back in the 70s and the 80s, and did a lot of work to get commonality in our systems around the world and across our technologies. And now, during the 90s, we realized that it was going to be awfully hard for us as an individual company to keep up with the pace of change, and made the decision to to start looking for a partnership with another company. ABB has been one of our key partners there with Roman Haas. We also brought in some new legacy systems that we have to deal with. And I think the key for us is really understanding what you have. right? Taking inventory of the systems, you know, doing the risk analysis on how long these things are going to last, you know, what your ability to service the legacy systems are for how long, and coming up with a, you know, really kind of a multi-generational plan around replacement and upgrade, but trying to be smart about how we do those upgrades so that we're having technology that, you know, we won't end up in the same spot we are now, partnering with different companies to have technology that can be upgraded and can be sustained and can stay on the leading edge as we go forward. But tremendous effort, tremendous costs, but, you know, if you take it as a structured approach and really work it across all of your assets, right? It's not a plant by plant decision, but a corporate strategy, making use of all the you know, the equipment that you have in house to best sustain you for as long as you can, and prioritize those replacements when you do them.
I just came from Distributech, which is the trade show where they manage the grid and they try to figure out what to do for the next generation. And one of the comments that really stuck with me for part of the microgrid project in Southern California was that if you invest in resources, your prices are going to continue to go up. If you invest in technology, your prices are going to continue to go down. And I give one example there, and I've looked at solar cells, and they don't pencil out, and they're really very expensive. But a good friend of mine put solar cells on his house in Rancho Mirage, and it took him he put them in 9 years, or 6 years ago. They've paid out, and now he pays zero for his electricity in Rancho Mirage. So you really have to look ongoing on that. The other issue that came up repeatedly is that one of the reasons that some alternatives like cogen or CHP don't pay out is this schism between utilities and the users, that you try to put in a cogen plant, but then they require you dispatch it, or they pay you only avoided generation, which is a horribly low rate. So we have a lot of issues, cross-industry issues, that we need to solve, but we basically can't keep investing in resource-based strategies.
You know, alternative energies, again, aren't just a nice to have. We have to have them. If you recall the chart that I showed about the demand and the supply gap, it's going to take not only conventional fossil fuels, but the full range of alternative energy strategies to be able to meet that growing gap. And I think some of the strategies that are being developed not only by industry but also by government are put some of the right incentives in place. One of the things I touched on about making carbon dioxide a valuable commodity in terms of just a gaseous waste is absolutely critical. And some of the work that's being done right now with regard to valuing CO2 is absolutely critical to driving it forward.
Just to echo that, to give you another perspective from a global perspective, it's hard for us to realize, sitting in this room, but there's 1.2 billion people in this planet that don't have a light bulb. And so as we look forward for alternative energy, even with nuclear, coal, and alternative energies, that number is expected to grow from 1.2 to 2 billion over the next 20 years. So the answer is a diversification. And particularly in the U.S., there's energy security, energy independence, energy scarcity. So alternatives, the technology will pay out over time. And I agree with the other comments. I don't think we have an option.
Okay, good, excellent. We have a question.
Let me pick up on this point also. I think with all the focus then on alternative sources, we should not forget to optimize the installed base we have already. There's a simple equation. If you can save 1 kilowatt at the user side, it saves you 3 kilowatt at the utility side. And we have done this. I'm from German origin. You can easily hear it. I've had this debate with the environmental minister a few months ago. And there are plans to build 8 new power plants. If the German industry would just save 5%, just 5%, we could just cancel the investment of the 8 power plants. Just to give you an idea. And 5% is with existing technologies. It's easy. It's absolutely easy to achieve. This is, let's say, within Schneider Electric, this is one of the key initiatives we have, really to assure that we have, really from a device level up to the MES level, a seamlessly interoperability, interconnectivity. Second, really to support with our plant structure architecture all kinds of interface technologies which are very common in the market, in order to make it really easy for the customer to hook on existing systems, have a part of new installation, and making sure that the process relevant data from the device level is really available at the MES level. And second part is what I tried to explain also early on, to get rid of the communication barriers between the power installation and the automation installation, and again, make it available at the top level.
I'll give you some statistics. We carry right now 450 interfaces. Even though half of everything we shipped is OPC, we still have 450. And when I started the company in 1980, I said, well, we'll just do interfaces, we'll do lots of them, and then they will go down with time. And that's not the case. A third of all of our development are new interfaces, upgrades to interfaces, and et cetera. So I don't think there is any real huge epoch answer for your question. It's just hard work, and you have to keep getting them. I will say what I've seen change, though, is that over time we used to put in systems that looked at particular facilities maybe identified by the DCS or whatever they had. Today we're putting in systems that are identified by the applications they run, whether they be a CIS application from the ERP level or sustainability. And now you have no choice because Mother Nature sets what variables you need. So I think we just have to keep interfacing, and I don't think realistically we can expect to see a common interface, at least in my lifetime.
It's, you know, this integrated management system, it may be a little bit of a misnomer with this crowd, but it was not a lot about, you know, circuits and wiring and hardware. It was a lot about culture. It contained, you know, a strong element of lean, short interval control, and, you know, really focusing on the plants, what was important to them. The first part was in each facility was to go in and set you know, the KPIs for that plant with the business case, with the customer needs, what were the important things that they needed to be working at. A few of those we had common, of course, across the EH&S. You know, these types of things are certainly certain things that we want to measure and look at every day. But the others were really based on the, you know, the business needs, the plant capabilities, and where they needed to make the biggest gains. And then we would set up a series of meetings that would take place on a daily, weekly, monthly basis, defined who would be in those meetings, what they would be looking at, and then really paying attention daily to what we said we were going to do yesterday. Did we do it? What were the results? Were they satisfactory or not? If not, then what do we need to do differently? So really a lot about, you know, looking at the business case, the individual plant case, and then having the right people engaged in conversations around those metrics each and every day. And I would say, you know, kind of going back to the energy discussion, you know, on the plants where we went in, we focused on energy reduction. And, you know, in Dow's frame of mind, most of these plants were smaller, you know, batch type operation, so it's not running a chlor-alkali operation, not running a cracker. So maybe they hadn't had as much emphasis on that in the past, but we generally found 10 to 20% reduction in energy usage just through day-to-day monitoring of these things and optimizing.